Hi guys, my name is Charles Riggs. This is a demonstration, a presentation video on network forensics, and this would be for a high level, high technical level audience, specifically network administrators, network engineers that are interested in digging through their traffic, finding anomalies, and then being able to do some forensics on those anomalies, on those events, to paint a bigger picture of what has happened, what has taken place on their network. This is really important, especially with the recent intrusions in some of the very large corporations, Epsilon for instance, where they had millions of emails exfiltrated from their database. This is going to become a bigger issue here in the next few years as this happens more and more. Companies are going to look to their network engineers and look into how and actually ask them to protect their networks. They're going to look at their network administrators. Corporations that have already done this, and they've actually set up security teams. Some of these corporations have actually created SOCs, security operations centers, where people do this and look for these anomalies and intrusions on a 24/7 day-to-day basis. That's what they do for their job. Most of the companies out there, though, are smaller. They don't have the means or the manpower, and they look to their IT staff, their network engineers, network administrators. So this video, this presentation, I guess, would be for someone like that to understand how to look at their traffic as a whole. So before we begin, I just want to talk about my background, my experience. Currently, I work in intrusion detection, intrusion analysis for a major sector of the U.S. government. We monitor numerous sites all across the United States for anomalies, for threats, for intrusions, and this is a very high-level job, and it's a very intense job. But the neat thing is, what I've been able to take from this job, from the things that I've learned, I can help others understand, maybe in the private sector where it hasn't been that big of an issue now. But it is becoming an issue, and it will be bigger and bigger as we have more compromises, major companies being compromised. So, network forensics, what is it? What does it mean? Well, network forensics literally, to me, means taking different anomalies, different alerts, different logs from your network, from your traffic, and putting those together and painting a picture of what has taken place. Correlating events across the enterprise, maybe for the hour, for the day, maybe going back a year historically, and looking at what has taken place and what has happened on your network. Most people, especially network engineers and network administrators, don't like to get into the nitty-gritty of protocols and how protocols work. So that's what I'm going to talk about. I think it's a good baseline to go off of as we get into network forensics. We have to understand and have a good foundation of the protocols of the network traffic that we're analyzing first before we can go forward and detect anomalies. So I want to talk about TCP/IP first. TCP/IP, what is it? We hear it all the time. Two separate protocols consistently put together. Most people think about protocols as being separate. There's all these protocols out there. What do they mean? We have HTTP, we have SMTP, we have TCP/IP, UDP, we have POP3, we have a myriad, FTP, SSH, all of these different protocols. It gets overwhelming. So what they did is they came out with a model called the OSI model, and the OSI model helps us follow a specific order. Certain protocols belong to certain layers of the OSI model, and if we use the OSI model as a reference, which honestly, the OSI model in and of itself can be very confusing. I want to try to demystify the OSI model and demystify the applications and the protocols so we get just an easy understanding, so it makes sense before we dig into more of the network forensics. So we need to think about the layers of the OSI model and compare those to our protocols. and compare those to specifically a stack of protocols which are contained in a packet of information going across our network. We know millions of those packets are consistently flowing in and out of our network and around our network, and we want to be able to break those packets down. That's going to help us detect anomalies, that's going to help us correlate events, that's going to help us look at the traffic more in depth. And by understanding how those packets are put together, we can understand how the protocols work together and play off of each other, because they do. So, the layer 1 of the OSI model is our physical layer. If you think about that as our physical, the cables, the wires, the devices, everything physical, the electrons that go out, that physical layer is more wrapped around the OSI model than just being on the very bottom. It's wrapped around. That's what we have to work with as our physical media, our physical layer. Now, protocols and computers understand ones and zeros. We know that IP address is a virtual address. We know that the IP address works with a MAC address. Really, there's a translation for these devices to understand that IP address 192.168.1.10 belongs to a so-and-so MAC address. How does that work with our different protocols? Well, the translation between an IP address and a MAC address is done through a protocol called ARP. ARP helps us translate those two. ARP is a layer 2 protocol. Because ARP works with MAC addresses, which a MAC address, or the logical address of a device, a MAC address or hardware address. So we have our physical layer, we have our data link layer, which is going to be the connection between our logical world and our physical world. ARP and some other protocols that work in that. Layer 3 is our network layer. So layer 3 is where we get into the more virtual world of the OSI model. Layer 3 is where IP comes into place. IP is a layer 3 protocol. All IP is doing is it's routing packets from one device to another based on the device's IP address. That's it. We know the IP in and of itself is not a reliable protocol. We actually, all its job is to route from one place to the other. As far as putting data in an IP protocol, we don't do that. It doesn't happen. So we use a next level protocol, a layer 4 protocol, a transport protocol, to make sure that we can take data, cram it in that protocol, and send it. So what we have in our stack now is, in our packets going across the network, we're going to have our Ethernet header, which is going to contain two MAC addresses, our destination and our source address. Next, we're going to have our IP protocol. After that, we're going to have our transport protocol. Now this could be UDP or it could be TCP. And then usually after that, we're going to have a higher level protocol, an application layer protocol like HTTP. This is commonly what you'll see on your network. Being able to look at those protocols and see how they work together. IP getting a packet from one place to the other. TCP making sure that packet got where it was going. HTTP containing our HTTP commands and our data writing on top of TCP. That's how that works together. That's how all of those protocols flow. They all work together in a stack. They're all doing a specific job. Ethernet, he's handling the MAC addresses. IP's handling those IP addresses from one point to the other. TCP making sure that our packet got from point A to point B completely with no packet loss. And then HTTP, our application layer protocol, that's going to present those commands, that's going to present that data to the browser itself, to the computer. So understanding how the protocols work together and how they come and how they equate to the OSI model is very, very important before you begin network analysis, before you begin network forensics. The next video would be analyzing traffic through a couple tools, TCP dump and Wireshark specifically. Wireshark will help us break down these protocols, help us understand how they work in the stack, how they work off of each other. Thank you.